So today we are going to discuss about 2 points. First one is transformation of energy, and the last one is law of conservation of energy. Okay, so the last class we were discussing about different types of energy. Okay, so we have already seen what is the transformation of energy. What is the transformation of energy? So transformation of energy we can define like this: the change of energy from one form to the another form. Simply in one sentence we can say the change of energy from one form to the another form is called a transformation of energy. Transformation of energy. Now, for the transformation of energy, the first day itself I have said, if we are considering about the photosynthesis, that means from the sun we are going to get a light energy. We are going to get a light energy. So if this light energy is falling on a leaf, then we can say that this light energy will be absorbed by the leaf, and through the photosynthesis, the leaves are going to prepare food. Okay, and they are storing that one as a chemical energy. They are storing that one as a chemical energy. So this is clear. This is clear. The light energy is converted into chemical energy. This is called the transformation of energy. So transformation of energy is the change of energy from one form to the another form. Then what will be the next example? Let's say if the light is falling on a solar panel. If the light is falling on a solar panel, what will happen? The light energy will be converted into electrical energy. Electrical energy. So this is one form of energy, and this one is converted into electrical energy using a device. Okay, and this is called transformation of energy. Transformation of energy. Then again, one more example. There are many examples are there. If we are considering a TV, yesterday we have seen. Is it now? Electrical energy will be applied to a TV. TV is a device which is going to convert this form of energy. TV is receiving only one form of energy, that is electrical energy, and this is going to be converted into light energy, then heat energy, and sound energy. So other three forms. So that's why we are telling that electricity or the electrical energy is the most convenient form of energy. That means we are able to transfer from one form to the another form very easily. Then there are some examples are given in your textbook. What are they? Light energy of the sun is transferred to a chemical energy of food during the process of photosynthesis. Already we have discussed. Okay, then next one. The water stored in dams possess potential energy which gets transformed into kinetic energy while falling. And this kinetic energy used to rotate the blades of turbine. At that time, what will happen? Turbine means the part of generator. At that time, this kinetic energy will be converted into mechanical energy, and this mechanical energy finally converted into electrical energy. That means we are having normally what in between two hills, the people normally make dams. There will be one big dam will be there. Okay, so from the rivers, normally water flows towards the dam. So when the water is flowing, which is actually it is a kinetic energy, because the water is moving. If the body possesses energy due to its motion, that we will call as a kinetic energy. And this is stored. That means we are blocking that flow. That's what called dam. Okay, we are blocking or we are storing water. At that time, it's not moving. It is not moving. So this one will become potential energy. This one will become potential energy. So kinetic energy is transferred into potential energy. Then from the bottom of this one, what will happen? A huge pipe will be there, penstock pipe will be there. And if we are opening this valve, suddenly what will happen? The stored water will start flowing. Start flowing. The water was not moving in the dam. Then when the valve is opened, suddenly the water will start flowing. That means again this potential energy will be converted into kinetic energy. This was at rest. When the body is not moving, it is having potential energy, and when it starts moving, this potential energy will be converted into kinetic energy, or will be transformed into another form, kinetic energy. Okay, and turbine means just like a fan leaf. There will be some leaves will be there, and this water is going to hit on one leaf. So what will happen? This leaf will start rotating. This leaf will start rotating. This is a part of a mission. Generator is a mission, right? And this kinetic energy will be converted into mechanical energy. This kinetic energy will be converted into mechanical energy. Then again what will happen? This mechanical energy will be converted into electrical energy. And the electrical energy which is the output of the generator or the mechanical energy, we are free to transform into any other forms of energy. That means in daily life we used to charge our phone. Okay, mobile phone. When we are charging the mobile phone with the electrical energy, what will happen? The energy will be stored in the battery in the form of chemical energy. Okay, and when we are using the mobile phone, we will get a light energy, we will get a sound energy, as well as some form of energy will be lost in the form of heat energy. Okay, or when the electric bulb is switched on, then what will happen? Normally our main aim is light energy. Okay, but along with that light energy, some amount of energy will be wasted in the form of heat energy. Okay, so in the light part, the bulb what happens is given there. When an electric bulb is switched on, electric energy will be changed into light energy and heat energy. Then, when a car engine runs, the chemical energy of fuel, already we have seen, petrol and diesel will come under chemical energy. Yesterday's class we have seen. Is it now? So, when the car engine works using this petrol or diesel, chemical energy will be there. This chemical energy will be converted into what? Heat energy will be there, sound energy will be there, kinetic energy will be there. For when the body is moving. Okay, so this transformation of energy from one form to the another form is called as a transformation of energy. Clear now? This is our first topic what we are discussing. Now, we are going to move. Next one is law of conservation of energy. Okay, law of conservation, very important rule, law in the field of physics. Law of conservation of energy, we can define like this. Energy can neither be created nor be destroyed. We are not able to create any amount of energy and we are not able to destroy the energy. Okay, but what happens to the energy? Energy will be always converted or transformed from one form to the other form. One form to the other form. This is called law of conservation of energy. Law of conservation of energy. SI unit of energy was joule. Is it now? So that's what I am telling. If I am, we can explain like this: 100 joule of electrical energy I am supplying to a TV set. Okay, in the home we are having 100 joules of energy. Suppose just simply I am telling that 100 joule of energy is converted or given to a TV set. Okay, so I am giving total of 100 joule of energy. And from TV we know the light energy will be there, then sound energy will be there, and finally some energy will be there in the form of heat energy. Okay, now when we are calculating the percentage, sometimes 70% of light energy will be given out. That means 70 joules. 70 joules of light energy will be given, the energy will be converted in the form of light. Then maybe 120% or 20 joule of energy will be converted in the form of sound energy, and remaining 10 joule will be converted in the form of or lost in the form of heat energy. Okay, so this total will come 100, right? How much I have given? That is 100. So this is called the law of conservation of energy. We are not able to destroy any amount of energy. How much energy is there, what we are applying, that much energy we will get as a output. Okay, so when we are considering about the universe, when we are considering the total universe, the energy of the total universe will be always a constant value. Okay, we do not know the value, but we are telling that the entire energy will be always a constant value. Okay, and this can be converted. Sometimes heat energy will be high, sometimes light energy will be high. If the heat energy is high, sometimes light energy will be reduced. Okay, so if any one form of energy increases, other form will be automatically decreases, and result will be always same. Result will be always same. Okay, then yes, on page number 38, the definition is given. What is the law of conservation of energy is given. What is the bold letter is given. Energy can neither be created nor be destroyed, but can be transferred from one form to the another form. This is called the law of conservation of energy. Law of conservation of energy. Then some examples are there. When a body falls from a certain height, its potential energy gradually changes into kinetic energy, but the total sum of the energy at every point during this motion always constant. Suppose if I am keeping one stone at a particular height, this much height I have kept. Okay, or I am just holding a stone at a height on my hand. So at that time this is not moving. It is not moving. So I can say that how much, for example, 100 joules of energies are there. 100, that means potential energy will be equal to 100 joules. Since it is not moving, there is no kinetic energy. So what will happen? Kinetic energy will be 0. The total energy will be 100 joules. Clear now? Now, if I am just releasing the stone from my hand, at that time what will happen? It will start moving. It will start moving. If I am answering 1/4 time half, that means I am divided this one into equal 4 parts. If I consider this part, what will happen? This potential energy sometimes will be, it will start converted into kinetic energy, maybe 75, and kinetic energy will be equal to 25. Then the total energy will be equal to 100. Okay. If this is on halfway, then I can say that the kinetic energy will become maximum. Is it no? Or we can say halfway, it is 50, then potential energy is also 50, the total energy will be remaining constant, 100. And when it is almost 1/3 part it is reaching, and then what will happen? The kinetic energy will be 75, potential energy will be equal to 25, the total energy will be 100. And when it is at the ground again, what will happen? It is at rest. Motion will be stopped now. At that time what will happen? The kinetic energy will become 0, and the potential energy will become maximum. So the total energy will be 100. Total energy will be 100. So that's what the first step it is explaining. When a body falls from a certain height, its potential energy gradually changes into kinetic energy. From each stage, potential energy changes into kinetic energy. Right now, the first time potential energy was maximum, then it started reducing, and at one point sometimes what will happen? The potential energy will become 0, kinetic energy will become maximum. Then again, when it is at rest, what will happen? The potential energy will become maximum and kinetic energy will become 0. This is actually what transformation of energy only. We are transforming energy from one form to the another form, but the total energy will remain always constant. This is called law of conservation of energy. Law of conservation of energy. Clear now? Then again, one more example is given in your textbook. What is that? Roller coaster. Have you heard about roller coaster? It's there on page number 38. You can just look at the figure 3.11. Okay. In amusement park and all, you might have seen that roller coasters are there. Normally they are just falling or different shapes of the wings, and at height it will start. Then there will be some difference will be there like that, and finally it will go to rest. Okay. So here also we are considering about potential energy. Okay, if I am considering here, if this body is at rest, the potential energy will be equal to maximum. As we have said 100 joules, no? If I am telling that this is maybe 2000 joules. Okay, and the kinetic energy will be equal to 0. Kinetic energy will be equal to 0. And when it starts rolling, then what will happen? Sometimes the potential energy will be equal to 15,000. Okay, 15,000. Then at that time, the kinetic energy will become 5,000. So the total will be equal to 20,000. Okay, again, if we are considering at the middle and all, when it is falling down, we know when the body is moving downward, the kinetic energy will start increasing. When the kinetic energy is increasing, potential energy will be decreased. Okay, and when we start climbing at a height upward, then what will happen? The speed will be reduced. So kinetic energy will be reduced and potential energy will be increased. But whatever happens, the energy of this body roller coaster will remain as same at every point. And finally what will happen? If it is reaching at the same height, what will happen? It will stop there. and then what will happen? Potential energy will be equal to maximum, kinetic energy will be equal to 0. Okay, this is called law of conservation of energy. Clear now? These are the two examples for the law of conservation of energy. Okay, so what is law of conservation of energy? Energy can neither be created or not be destroyed. We are able to change this energy from one form to the another form. Clear now? Then there are two key points are given. That's what same what we have discussed on page number 38. The law of conservation of energy is true for all the bodies and for all forms of energy. Even though we have discussed only potential energy and kinetic energy, then we have discussed about electrical energy in the regarding TV. Whatever be the form, all forms of energy, this conservation of law of energy is applied. Okay, if we are just considering light energy and electrical energy, how much light energy is received, that much electrical energy will be produced. Okay, mechanical energy, how much work I have done, that much energy will be stored in the form of potential energy. Okay, so everything is like that only, whatever be the form. If one energy, suppose if heat energy is, when the TV is working, I said that some amount of heat energy is produced. But actually that heat energy we are not using. But that energy is not destroying, that will be given to the surroundings. That will be given to the surrounding. When the light is working, we are having light energy only, we need only light energy. But some amount of heat energy is produced, that energy is distributed to the air. That means that energy is not wasting, it is distributed into air. So everywhere this transformation will be same and the resultant value will be a constant value. That is the law of conservation of energy. I think you understood these things now. Then most energy transfers loses energy. However, the energy does not disappear. It usually goes into the surroundings. That's why we have to keep it in mind. Sometimes there will be some doubts will be there now. When one body is, if we are kicking a football, it will be having some amount of energy. Then it will start rolling, is it not? And when it needs to roll, at the time what will happen? Frictional force will be there. That will be opposite. It has to overcome that one. So some amount of energy will be lost in order to overcome the friction. Okay. At that time, we cannot say that energy is vanishing. That the energy is just distributing towards the surroundings. Okay. So that's why energy is said to be, energy is always conserved. Energy is always conserved. It's clear now? So this is about our chapter. Now we will move to the exercise portions.